The ocean is our planet's life support system. The ocean regulates the climate, absorbs huge amounts of carbon dioxide from the atmosphere, and provides us with vast stores of food. Population growth, rapid infrastructure, our changing climate, and events happening far away in the polar regions are impacting the ocean and threatening all aspects of life across Southeast Asia.
What we've discovered from the supercorals here in these urban oceans and how they've built their resilience can teach us a lot about how we can protect and conserve fragile coral reefs.
The connection between a healthy ocean and healthy people is nowhere more obvious than in Southeast Asia.
What I'm worried about in the next 5-10 years is that these bleaching events are becoming more frequent and they will become more widespread.
We have so much to learn, and we have so much to contribute to being part of the solutions for our changing oceans.
Dive with scientists from the Earth Observatory of Singapore as they investigate the impact climate change is having on the ocean, explore engineering ideas for artificial reefs, and discover a coral species showing resilience to climate change. Could these supercorals be part of the solution?
Most people don't realize that the oceans contribute up to 70% of the world's oxygen supply. And coral reefs are really the rainforests of these oceans. They are the lungs of the sea, and they support huge amounts of biological productivity and biomass. The global epicenter of coral diversity is right here in Southeast Asia, in an area known as the Coral Triangle. So the Coral Triangle is a roughly geographic area that spans warm tropical seas between the Philippines, Papua New Guinea, and Indonesia. And it's inside this geographic boundary that we see over 70% of the world's coral species, a huge variety of reef fishes, and a number of other organisms that live in marine ecosystems. Because coral reefs are such an important marine habitat in Southeast Asia, understanding how they react to global pressures, to climate change, and to increasing human activities is really critical for understanding global ocean health and ultimately our own survival.
Scientists at the Earth Observatory of Singapore, monitoring the health of coral reefs in Southeast Asia, have made an unusual discovery in reefs that inhabit urban ocean areas. While many coral reefs around the world are declining rapidly, some urban corals are showing resilience to human activity and climate-induced stresses. They call them supercorals.
Urban oceans are areas of the coastal seas that inhabit marine environments nearby large urban centres. So these typically exist adjacent to megacities, which are areas of very high population densities, urban development and infrastructure. And this places a lot of pressure on the marine environment in terms of increased sedimentation from land runoff, boat activity. When we think about Singapore, this is one of the busiest ports in the world. We have huge amounts of ship traffic coming in and out of Singapore's coastal area each day. And this places a lot of pressure on the natural marine environments that live in the waters surrounding Singapore.
Local human activities are impacting the health of coral reefs across the world. Here in Southeast Asia, the combined impacts of climate-induced stress and human activity threaten the existence of ocean habitats across the region.
What's also concerning is things like increasing ocean temperatures, which can cause coral bleaching, also rapidly increasing rates of sea level rise, which can start to drown some types of reefs, particularly in these urban areas, because urban coral reefs live under these sort of low light conditions. They're very light limited because of the poor water quality and the high suspended materials in the ocean.
To date, marine research has largely focused on the declining health of pristine coral reefs. Now, scientists in Southeast Asia are focusing their research on urban coral reefs that are showing significant resilience and could provide clues to save coral reefs in decline around the world.
So what we are starting to do with our research is try and understand some of more of these marginal and more extreme environments where corals live as a hope to understand how they begin to cope and to tolerate these more marginal conditions for growth. And the idea that this can give us some sort of hope about the future resilience of reefs and understanding how other reefs will then respond to changing environmental conditions in the future. Hey, how you doing?
Today, Kyle is joined by Dr. Natasha Bhatia, a marine ecologist from the Asian School of the Environment. They're taking a field trip to replace scientific equipment monitoring urban coral reefs, showing resilience to environmental changes in the Straits of Singapore.
What gear have you got with you today?
We've got some transect tapes, we'll do some ecological surveys,
Awesome.
and then I've got a bunch of environmental loggers that we can put out so we can start measuring some of the conditions that these corals are growing under. We're heading out today to Pulau Hantu, which is an island and reef system in southern Singapore. And we're going to be taking a few dives to get close and personal with these resilient coral reefs. We want to understand how they're growing, and we're also going to be changing data loggers to look at the environmental conditions under which they're living. A lot of people don't realize that corals, although they are the engineers of these underwater megacities, and they provide habitat and structure for organisms and fishes that live in and around the reefs, they're also animals themselves. And if we lose them, they can take multiple human generations to be restored back to their original states. So by protecting and conserving coral reef ecosystems, we can protect global ocean health and ultimately our own survival. I think we'll do 2 dives today. The first one this morning will be on this western side of Pulau Hantu.
And the reef is just along the seawall here, right?
Yeah, it kind of extends along the seawall, really close to shore. So we'll jump in and have a look at how the corals are doing and the coral communities and how healthy they are.
Great.
Yeah, and then we'll put some loggers in to record what the conditions are at this site.
And then the second dive?
Yeah, so we'll head around the jetty, around this northern point.
Great.
The corals are a bit different here and there's more algae, so we'll try and figure out why that kind of is. So we'll, again, put some more loggers and other things in there. I think there's been a big focus on these more charismatic locations and these coral reef systems where people want to go and see on holiday and dive on. Traditionally, they haven't been studying these coastal environments and areas located next to major megacities because there's deemed to be less aesthetically pleasing, or the diving conditions and visibility are poor that you can't really see the communities. So that has led to basically big gaps in our understanding of these reefs as an ecological system and also how they benefit the coastal communities. Right, once we geared up, we'll just get the equipment and then we'll jump off the back of the boat.
Excellent. So the first equipment that we have to put down is the loggers, right?
Yeah, so we have a turbidity logger that measures the clarity of the water over time. We also have a light logger which measures the amount of light that the corals are getting. And we also have a wave logger which records both tides and the amount of wave energy that this site is getting.
Okay. So I'm really excited about getting in the water today and seeing what the health of these reefs is like. The long-term data sets that Kyle and his team are putting together are really valuable resources to help us create educational materials so we can translate the importance of these reefs for educational purposes. Yes, all good.
All right, you ready?
Ready?
Okay. 1, 2, 3. The local water quality and high turbidity in the seawater means that we're really diving here at the limits of where light can penetrate deep into the ocean. This means that corals have had to adapt and to build their resilience to these low light conditions within these urban oceans. Here we are looking at one of these super resilient coral structures that we have in the waters around Singapore. Many of the corals grow laterally and spread out along the reef surface, and others have very long extended tentacles that flow in the water column. Both of these designs and shapes allow the corals to adapt to these environmental conditions. The coral composition and communities that we get in these urban waters differ from those on more pristine reefs. They need to be more stress tolerant, and the shape reflects this. Today we are changing out some of the data loggers that measure ocean temperature, as well as some of the apparatus that we use to measure how much sediment is accumulating on the reefs.
Oh, it was great. It's good to see the corals are doing really well. I mean, one of the things I noticed most was the diversity of corals that you don't see on other reefs. Particularly, you see a lot of these corals that have their tentacles extended so that they can feed. Because these are quite low light conditions, so they need to supplement their food source with stuff that they can find in the water rather than sunlight.
It's important to study ocean adaptation so that we can better understand how some oceans have begun to build resilience, and if these adaptations can then be applied to help save fragile ocean areas where change is starting to happen faster than adaptation can occur. I'm hopeful that we can then understand how to propagate these supercorals like we see in these urban oceans and implant their strength and their resilience into more fragile coral reef systems in an effort to stabilize coral decline and to stop the mortality and death of coral reefs from around Southeast Asia. But there's not a lot of time left. What we've discovered from supercorals and their ability to build their own resilience can teach us really important lessons into how to protect and to conserve more fragile reef systems.
I've been a witness to a dramatic shift since the middle of the 20th century when I began exploring the ocean, from a time of this enormous prosperity to a time of enormous loss. About half of the coral reefs around the world have either disappeared or they're in a state of sharp decline. It's projected that by the middle of this century, most coral reefs will be gone if continuing to decline at the current rate. So it's a combination of planetary warming, the taking of many of the creatures that are vital to the system, the fish, parrotfish, all the fish are part of the system, and even crustaceans. We think of coral reef as a source of what we can take out of the systems, but every piece has a place. And by taking too much of the wild creatures that are associated with the corals that form the structure, we have really set in motion this decline. So, the many ways that we are impacting the coral reefs, or in turn, the loss of those reefs are impacting the health of the ocean. To help support the health of the ocean and coral reefs here in Southeast Asia, an innovative new project created by JTC, the National Parks Board, and support from the scientific community has launched the country's largest artificial reef project. This vertical structure has been created to try to attract coral growth in and around urban ocean areas. But how do you encourage corals to set up home? Well, a group of engineers think they know just how to entice them. Professor Chu from the School of Engineering at Nanyang Technological University was part of the scientific team who designed the coral platforms and the special materials chosen to coat the frames to attract the corals.
So this is our own coral cultivation tank.
The objectives of this project are to try different ways to see how to cultivate the coral reef artificially or to accelerate the cultivation of a coral reef in a marine environment. So one of the ways is to coat any subjects, such as glass fiber with a layer of pure calcium carbonate to facilitate the cultivation of a coral reef in the ocean. So the methods have been developed so it can be adopted in other parts of the world and as a mean to accelerate the cultivation of coral reef to restore our marine ecosystem.
This 10-meter-high marine structure has been designed to use the entire water column from the seafloor to the surface that sits in an urban ocean area to attract different types of corals and other marine life. Here at the St. John's Island National Marine Laboratory, scientists working in aquarium labs are modeling future oceans to look at the impacts of climate and human-induced stress on corals, how resilient they are, and what thresholds might be critical to ocean health.
In the Control Environment Aquarium here at the National Marine Lab, we have various tanks in which we can manipulate temperature, pH, light, salinity, and nutrients. Basically, we can manipulate a whole bunch of environmental conditions to mimic certain environments, even climate scenarios in the future. Both climate change-related parameters as well as other environmental disturbances that are related to a bit more anthropogenic impacts like nutrients and sedimentation and even salinity.
Feeding time in the research aquarium captures some amazing activity from the corals rarely seen. Even corals look forward to their feeding time, and for them, it's a few grains of rice. Adjacent to the aquarium labs are a set of coral nurseries. Here, scientists are cultivating young urban corals to trial reseeding declining reefs in the future.
I want to show you our vertical farming coral culture tank. So here what we're trying to do is to build HDB blocks out of these building blocks. Yeah, try and grow as many corals as we can. We're hoping to scale this up to larger tanks, and then we'll be able to grow more corals that we can then use for research and also for other restoration purposes.
By combining research work in the field and in the lab, scientists in Southeast Asia are playing a lead role in accelerating the knowledge on how to support important reefs like the Coral Triangle in Southeast Asia and important marine habitats around the world. One scientist well known for his work mapping the Amazon rainforest is using his knowledge to build the first global coral reef atlas, high-resolution images that will form a monitoring system for the health of coral reefs this century. From his Hawaiian Institute, Dr. Greg Asner and his team run the Paul Allen Coral Atlas program, allowing scientists, conservationists, and governments to track and monitor the changing impact of climate and human-induced stress on the world's coral reef systems.
My career actually started in ocean science, but then I discovered the Amazon basin and I spent more than a decade there studying rainforests. And those studies were focused on rainforest biodiversity, carbon stocks, and other issues, using our aircraft technology and satellite technology together. During those years, we created new methods for probing biodiversity, and later on, I discovered that those same methods could be reapplied back to ocean systems. So some of the methods we created in the Amazon basin, we're using them today to map coral reefs from the air and from space. While we've been doing work on land, we realized that coral reef ecosystems were declining faster than almost any other biome. Coral reefs are spread across the planet in a very complex pattern that makes them hard to understand, hard to study, and hard to manage. Yet doing so is absolutely central to the health of our entire ocean system and, in fact, to the planet's biodiversity and its functioning as a whole. Back in 2017, the late Paul Allen, the co-founder of Microsoft, convened a group of experts, and I was lucky to be in that group, to talk about and envision what types of global scale science and technology could help us carve new pathways for coral reefs. With his backing, the group and the partnership was formed to create a very high-tech platform for not only mapping coral reefs, but for monitoring their health over time. The Island Coral Atlas has achieved 2 milestones so far. One is a globally consistent, high-resolution set of maps of where our coral reefs are located and their basic composition. Believe it or not, prior to 2021, that didn't exist. On top of that, we've created and deployed the very first coral reef monitoring system. The monitoring system is going to expand into the future, but in 2021, we already launched a major portion of this monitoring system. It's called the bleaching monitoring system. It allows us to identify where corals are under stress from a variety of factors, including climate change, and to identify where they're bleaching and where they're also getting through these bleaching events.
Scientists here at the Earth Observatory of Singapore are working, really committing to enhanced study of coral reefs and the surrounding ocean. The next 10 years are critical. This is a time as never before, maybe as never again, for actions to understand the ocean and to make the link between what's happening in the ocean with climate, how all of it together comes back to affect the survival and the well-being of people here in Southeast Asia.
So I really hope that my research fills this gap in understanding that we currently don't have of these sort of more urban and extreme environments, so that we can begin to understand how they became so resilient, how we can also help other reef settings in the future, and how we can also start to mitigate and conserve other reef environments where urban stresses may not be so severe at the moment, but are rapidly increasing. And I think this is a really key lessons we can learn from these already urbanized reefs, how to sort of safeguard coral reefs around the region and provide some sort of conservation protection.
A healthy ocean, brimming with life, makes life on Earth possible. Now we know the ocean drives climate and weather. It's home for most of life on Earth, including the greatest diversity of life. Now we also know that we are agents of change, and we know that here in Southeast Asia, it's possible to take action to protect those systems that create a healthy ocean and underpin not just our prosperity, but our very existence.